Hello, in this presentation I'd like to talk about calculating capacitance in parallel and in series and how that's different from calculating resistors in parallel and series circuits. So let's start off by explaining this drawing on the board here, where we've got a simple parallel circuit with two capacitors, both 10 farads each, and a 20 volts supply coming into this. To be able to calculate the total farads in parallel is exactly the same as we calculate the total resistance in series. So we just add it up. So this is a pretty simple calculation to start with. So the calculation here for total capacitance is simply 10 farads plus 10 farads, so 20 farads. So let's put that in down here. Total capacitance 20 farads. So now that we know the total capacitance, we can now work out what the total charge is, which is very important because we're working out this little triangle over here which stipulates that voltage times capacitance gives us the Q factor. The Q stands for coulombs. So 20 times 20 will give us 400 coulombs. So we're going to write that answer in there. So we can in 400 coulombs, and so that's about all we really need to know about this particular calculation. Just to check that it's correct, of course, we divide the 400 coulombs by 20 farads to get the 20 volts so that we know that it's the right supply. Now these simple numbers, it's fairly easy to see that that's correct. You might have a parallel circuit with several different sized components, but in doing these calculations, as I've shown you, just by adding them all up and then multiplying them by the voltage, we should always end up with the same amount of voltage. Let's have a look at the series one now. So in this series capacitance circuit, so I've left the voltage which was calculated for the resistors behind just to remind us what we had, and we had a voltage drop over 10 volts over each component. Remember, in series it's a voltage divider, and in parallel it's a current divider, and this applies both to resistors and capacitors alike. So with the resistors we just added them, but with the capacitors we need to add them and have this reciprocal function done. So to add the total capacitance we need to bring our calculator over, and we'll do the calculations the same as what we did with resistors in parallel. So there's 10 farads 1x plus 10 farads 1x equals that 0.2, and then the 1x gives us a total of 5. So that is the total capacitance. If they were resistors, it would be a total of 20 farads, but here it's a total of 5 because they're capacitors. So let's put that result in. Now, of course, we'll look down at the triangle here, and we know that voltage times total capacitance would give us the Q factor, or the total coulombs, total charge. So if we were to do that, multiply the 5 by the 20, we'll end up with 100 coulombs. So let's put that in now, 100 coulombs. Now that we have this 100 coulombs, we can then just look at this circuit and very simply provide some answers here. So 100 divided by 10 would give us 10 volts. 100 coulombs divided by 10 farads would give us 10 volts. And 100 coulombs, of course, divided by 20 volts would give us 5 farads. So the numbers sort of work out nicely there for us, and everything seems to be calculated out correctly. By reverse sort of calculations, we know that we've gone the right track here. So I hope this has helped in going forward, going through calculations with voltages and currents and capacitance and charge, and of course all of these things that are important to us in the electrical industry. We need to understand how these things operate in series and parallel. I hope that's helped. So thanks very much for tuning in, and if you like it, give me a thumbs up. See you next time.